Create a setup sheet. After completing this video, you'll be able to create an NC program and produce a setup sheet for each operation. In Fusion 360, let's carry on with our 3-axis sample and make sure that we do have both Op1 and Op2. Let's do a quick check by right-clicking and editing Op1 and remembering our post-process settings. Our program number was 2001 with 3x Op1 as our program comment and WCS offset of 1. If we take a look at Op2 and select Edit, we can see here that post-process program number is 2002 and there's no comment currently in here. So we're going to put a comment of 3x Op2, and once again it's using the WCS of 1. We've got both operations set to machine our part with all the toolpaths needed, noting that we did leave a few suppressed toolpaths inside of each operation. In order to post-process and create setup sheets, the best option for us is to create what's called an NC program. An NC program can be a grouping of individual toolpaths, entire setups, or multiple setups altogether. It allows us to predefine things like our post-processor or the way that we're going to convert these toolpaths to machine-readable code. To get started, note that Op1 is currently active. We're going to go to our Setup dropdown and select Create NC Program. When we do this, we're prompted with an NC Program screen that has a Settings tab and Operations tab. Notice in the Operations that we have our operations listed here and our settings listed on the first page. For our post, we're going to be using our NGC, or Host Next Gen Control. If you have a different post that you wish to use, then make sure that you do search for that. You can choose from a library, and when you search the library in Fusion 360, you can have a stored My Post in the cloud, local, or a linked library. And in Fusion 360 library, you can use your filters to search by capability as well as vendor. In this case, the Host NGC, or Next Gen Control, is going to be the best option for us. But again, if you have a different post, then make sure that you do select it. Notice that when you select a post, it's going to ask you if you want to use it from the Fusion 360 library. Keep in mind that posts here do get updated frequently. So if you're making any changes or you do have a post processor that is known to work and you want to isolate that, then make sure that you do save it to a local or cloud location to use. In my case, I'm going to select Use Anyways. On the right-hand side, we have post properties. Now, these are individual options that can be configured based on your specific machine. For example, if we expand configuration, we've got chip transport, whether or not this machine has an A, B, or C rotary axis, and these will allow you to post the applicable code for your machine. Keep in mind, if your machine does not currently have an A axis enabled, if you enable this, it'll likely throw an error when you try to read the code. Also note that we have Machine has Tool Setting Probe Arm. So these are important configurations that might need to be turned on based on your machine's functionality. As we go through here, I'm not going to go through each setting, but it's important that you do go through and figure out what works best for your machine. Or once again, if you have a known post processor, make sure that you use that. We can also determine whether or not we post our NC code to Fusion Team. If you are sharing the code on Fusion Team as a way to get it to your machine, it's important that you determine the local output folder and your post to Fusion Team location. For this example, I'm not going to post to Fusion Team, but do want to note that our 3x Op1 and 2001 program number have come in from our comments. In the operations section, this is where we're going to determine which toolpaths we want to post inside of this NC program. Note that even though Contour 1 and Contour 2 are checked and selected, because they were suppressed inside of our setup, they are not shown as being posted. We only have our adaptive operation, our parallel, and our flat. We can post directly from here, but for me, I'm going to select OK, which is going to put the NC program in an NC program folder. I'm going to reset it, and I'm going to call this NC Op1. A good check for this is to right-click and note that we have our Simulate options, we have Post Process, and Setup Sheet. When we select Simulate, this is going to simulate only the toolpaths that are going to be posted. So it's a good final check for you to play through and figure out which toolpaths are going to be included inside of your posted code. Make sure that everything is machined properly, and then you can post your code or create your setup sheets as needed. Before we create our setup sheets, let's create another NC program for Op2. Notice that Op1 was already pre-selected and active, so it's pulling in the information from that. It's important that we do pre-select and activate Op2 to make the NC program process a little bit easier. While you can determine which ops and toolpaths you want to use at the time of NC program creation, pre-selecting your setup will bring in the program number as well as the program comment for you. Once again, make sure that you do specify the correct location, your program name or number, and whether or not you want to post it to Fusion Team. Your post-processor configuration options should remain, but double check that you do have all of the settings toggled on that you wish. In the operations section, once again, the toolpaths that are suppressed are still listed here and checked, but they are not posting because they are suppressed. Note that we do have an option to reorder to minimize tool changes. This generally applies when you're using multiple setups across multiple coordinate systems. This allows us to reorder the operations based on the tool that's currently being used. It will not reorder your operations in a single setup. However, it will allow you to move operations from multiple setups up in line to use the same tool and minimize tool changes. It's important to consider factors like the distance between multiple workstations on your machine and how long a tool change actually takes. Tool changes happen relatively fast on modern machines, probably about the same amount of time that it takes to wrap it to a secondary fixture than it does to change the tool. But once again, we're going to select OK to create our NC program, and we're going to rename this NC Op2. Once we have both of these inside of our browser, we can determine what we want to do from here. Once again, we can post a code which converts it to machine-readable G-code based on our Haas Next-Gen Control post processor. We can create setup sheets or we can simulate. From here, I'm going to select NC Program Op1, right-click, and select Setup Sheet. When we create a setup sheet in this way, it's going to publish it to our project location. Make sure that you do validate the location it's being saved. If you've saved any designs previous to this, you might want to double check your location just to make sure that it is going to the right place. Once we select Save, that 2001 setup sheet is going to be saved into our project. Note that we now have what's called a configurable setup sheet. I'm going to expand it so we can get a little bit better view. At the upper right, we can print this view out. Of course, using your computer settings, you can print it to PDF or directly to a printer. As we look through here, we've got configuration options that allow us to use a detailed setup sheet, display only the tools, compact, and some other compact options with no images. We're going to take a look at the detailed option, which contains everything. First, at the very top, we have a summary that displays our program comment, the design document, the product version, as well as when it was created. We have the number of setups. In this case, we're only posting a single setup, Op1, number of operations, and number of tools. It tells us our min and max Z heights, the feed rate that we're using, and the spindle speed. These are important things to identify as a machine operator to make sure that you're not exceeding the machine's requirements. Next, we want to take a look at the tools used. There's going to be important information here. And again, in the tool setup process, if you included product links, those hyperlinks will be active inside of the setup sheet. This can be helpful for machine operators to validate things like the feed rates that are being used. As we go through, next we have our setup. Now we can see here that the setup is not looking quite right. This is showing the bottom of the vise and the orientation that we used for setup 2. So this is something that we need to correct and validate before we move on. The next thing that we want to do is we want to take a look at the operations. We can see that the WCS is currently 1, which is G54 in our case, and we can see the different strategies that are being used and the different tools in each strategy. Let's go ahead and exit out of this, and let's make sure that we activate Op1. The view that we see on screen is going to be the view that gets captured inside of that setup sheet. So now if we right-click on Op1 and we select Setup Sheet, let's go ahead and save it to the same location and the same name. And as we scroll through, we can now see that our setup image is showing what's on the screen. So that's an important consideration when creating your setup sheet, is to make sure that whichever setup or operation that you're identifying, make sure that you do have it currently active. We'll do the same thing and we'll create a setup sheet for Op2. In this case, notice that it's going to go to the same location. We're going to select Save and just validate the setup image. Once we're happy with everything here, again, we can print these out or we can share them directly from our project. At this point in time, nothing needs to be saved in the design, so let's go ahead and move on to the next step.